Hey everyone, welcome to The Explainer. If you're a cloud architect, a DBA, or an IT ops pro, you already know the golden rule. Visibility is absolutely everything. Blind spots? Yeah, they're your worst enemy. So today, I'm super excited to guide you through a highly practical architectural blueprint for extending your Oracle Cloud Infrastructure monitoring capabilities using the CLI. We're going to look at exactly how to capture those sneaky, unique data points that default monitoring might just gloss right over.
Let's start with a crucial gap we've all faced. Native cloud metrics are fantastic straight out of the box. They hand you CPU, memory, network I/O, the basics. But are they always enough? Frustratingly, no. They simply don't catch everything happening inside your specific application layer. Like, what if you desperately need to know the exact count of specific host-level Java processes running on one particular compute instance? Standard metrics just aren't going to give you that granular, customized detail.
Well, the solution to this visibility gap is OCI custom metrics. Think of these as user-defined data points that you collect yourself and publish directly into the OCI monitoring service. By leveraging custom metrics, you can track highly specialized workload performance. Whether you're spinning up a quick lab demo or monitoring a critical production process count, it completely bridges the gap between general cloud health and your unique operational reality. Okay, here's our structural roadmap for the explainer today. We'll start with the power of custom metrics, then move briskly into setting up your OCI permissions, constructing the payload, and executing that publish command via the CLI. Finally, we'll cover how to actually query those metrics, set up alarms, and quickly review the crucial limits you absolutely need to know before deploying. Section 1, the power of custom metrics, beyond default monitoring. So before we push a single byte of data into the cloud, let's establish exactly what we're trying to achieve here and why we're choosing these specific tools. We are focusing on a highly practical use case today. Sure, you absolutely can use the Java SDK or Python REST APIs to publish data. People do it all the time. But let's be real, those can be pretty clunky for a rapid proof of concept. Our target today is to capture a host-level Java process count and push it to OCI using the command line interface. You really want to frame the CLI as your secret weapon here. It's incredibly efficient for throwing together a quick testing case or a lab demo without having to write, compile, and debug heavy application code.
Moving right along to Section 2, setting up OCI permissions, the foundation. Because look, you can't just shove data into the cloud unannounced. You need the correct identity and access management policies established by an admin first, or your requests are just going to bounce right back. Now, when it comes to authentication, you generally have two paths. You can rely on a user OCI API key, which, means managing and securely storing local credentials, or you can take a much more modern cloud-native route by natively empowering your compute instances to just authenticate themselves automatically. If you want to avoid the absolute headache of rotating and managing static keys across dozens of servers, and trust me, we all do, enabling an instance principal is absolutely the best practice here. The workflow is actually pretty sleek. First, you rely on dynamic groups to logically bundle your compute resources. Then, you add instances to this group using specific matching rules. After that, you create a policy that explicitly allows that dynamic group to access and publish metrics. Bam! Completely seamless, keyless API calls straight from your instances. All right, Section 3, constructing the metric payload, crafting the postcard. Let's move into the execution phase and see how this builds into our actual data structure. We've got to construct our JSON payload, and honestly, it's exactly like filling out a physical postcard. Just like a postcard needs a destination, a sender, and a message to make sense, your JSON payload requires specific routing elements to actually reach OCI monitoring. Your OC telemetry URL? That's your destination address. The compartment dictates exactly where the metric lives organizationally. You've got to have a namespace to logically group your custom metrics together. And of course, you absolutely need the resource name and compute resource ID. Without those, you'd have zero idea which host instance actually generated the data point. Oh, and here is a classic gotcha. This one detail has caused countless headaches in cloud operations. Your timestamp has to be absolutely precise. To even be accepted by the ingestion endpoint, the timestamp needs to be perfectly formatted in UTC. So for those of you out there writing bash scripts for your CLI commands, using this specific date formatting string ensures your metric isn't silently rejected just because of some malformed or localized time string. Section 4, publishing via OCI CLI, executing the push. Okay, Permissions are secured, our JSON payload postcard is perfectly filled out. Now it's time for the climax of our technical action, actually firing that data up into the cloud. It literally all comes down to this single, powerful command in your terminal. You're going to run OCI monitoring metric data post. When you run this, you'll also use an endpoint parameter that points specifically to the telemetry ingestion endpoint. It basically grabs that JSON payload we just built and injects it straight into your cloud monitoring ecosystem. Boom, done. On to section 5, querying and creating alarms, the payoff. But wait, pushing data is really only half the battle, right? For us IT ops folks, raw data is completely useless unless we can visualize it and make it actionable. So let's look at the real payoff here. Once your CLI command succeeds and those custom metrics are successfully published, your next step is to query them directly in the OCI Monitoring Metrics Explorer. You'll see them right there as charts, exactly like your native metrics. Finally, to complete the whole loop, you set up an alarm. Think about it. If your custom Java process count suddenly drops to 0 at 3 a.m., OCI can automatically trigger an ITSM alert so your team isn't caught completely off guard the next morning.
And finally, Section 6, Crucial Limits and Considerations, the guardrails. As IT professionals, we all know it is absolutely vital to understand the constraints before we deploy and inevitably break something in production. OCI definitely has some specific guardrails you have to respect. I need you to burn this specific number into your memory, 100,000. That is the strict, hard maximum limit for data points returned when you query your custom metrics. When you're defining your metrics and playing around with time ranges and resolutions, you have to design with this return limit in mind. If your query tries to pull more than 100,000 data points in one go, yeah, you're going to hit a wall. Plus, there are a few other critical guardrails to keep in mind. First off, never, ever use Oracle reserved prefixes like OCI or Oracle for your custom metric namespaces. Just don't do it. Second, while you can technically publish data as fast as once every second, your minimum aggregation interval is 1 minute. Third, and this is a huge one for avoiding silent failures, ensure your timestamps are extremely close to the current time. OCI will flat out reject data if the timestamp is more than 2 hours in the past or more than 10 minutes into the future. And lastly, always watch your valid range of dimensions and maximum number of streams. Oh, and knowing this one tiny detail about null values will literally save you hours of debugging. When you're retrieving custom metrics, you can match them to a resource group, right? But if you query with a blank or null value for the resource group, it explicitly returns metric data that is ungrouped. Seriously, keep this hard-learned industry secret in mind when you're pulling your hair out trying to find the data you just published. So what does this all mean? Well, you've got the architectural blueprint now. You know exactly how to bypass SDKs for a quick CLI deployment. You know how to secure instances with dynamic groups, craft the perfect payload, and navigate Oracle's strict guardrails. So take a look at your own infrastructure today. What critical, hidden workloads are running in the dark right now, just waiting to be illuminated? The tools are right there in your terminal. Thanks so much for joining me on this explainer, and hey, happy building.